Hello everyone, welcome to our lecture number 3 of our chapter Units and Measurement, which is your first chapter of class 11. So, and in today's lecture we will discuss about your dimensions of a physical quantity. Dimension of a physical quantity. Okay, so what does it mean? Now see one thing. Suppose first see the representation. Suppose this is one physical quantity Q, and always remember its dimension is represented with the help of square bracket. That means square bracket represents the dimensional notation only. Square bracket means it is representing dimensional notation only. Okay. So dimension of Q, it will be the powers of M, L and T. M, L, T, theta, K, all these things. That means, suppose I am writing M, L, T. M power A, L power B, T power C. So listen one thing. What is the meaning of dimension? Dimension means these are the powers of fundamental powers of, here in our example, A, B, C are the dimensions of physical quantity Q in terms of mass, length and time. That means we can say in definition part, we can say dimensions of a physical quantity are the powers of fundamental quantity to which they are raised to obtain the physical quantity. Here, in order to represent the quantity Q, we are taking the help of fundamental quantity M, L and T, mass, length and time, and here mass power is A, L power is B and T power is C. So A, B, C are the powers of MLT. MLT are fundamental quantities, and these A, B, C are called dimensions of quantity Q in terms of mass, length, time respectively. Yes? Okay. So let's write the definition. So dimension of a physical quantity. Dimension of a physical quantity are the powers of fundamental quantity to which they are raised to obtain the physical quantity. To which they are raised to obtain the physical quantity. Yes, we are having 7 fundamental quantity. So let's write the dimensions of those quantities. Okay. So here I am writing fundamental quantity. There are 7 fundamental quantity. What are they? First is your mass, then length, time, temperature. Next one is electric current, shortly representing by E current. I am writing E current. Okay. Electric current. Next is your luminous intensity. And last one is quantity of matter or amount of substance. Quantity of matter, or you may write amount of substance. Then here we have to write the dimensions. Remember, the dimension of mass is M1, L0, T0, or you may write it as M power 1, simply M power 1, or simply you may write M dimension. Like this, the length dimension can be represented by L. Yes, time dimension is T. Then temperature, you may represent K dimension or theta dimension. Next one is electric current, I dimension or A dimension. Dimension A. Dimension A means what? Dimension A means M0, L power 0, T power 0, A power 1. Like this. Luminous intensity, CD dimension, M0, L0, T0, CD1. Amount of substance, MOL dimension. Yes, I hope it is clear to all of you. Okay, MOL dimension. So let's start to find dimensions of derived physical quantity. Yes, so many quantities are there in physics, but some general quantity dimension we have to find. Okay. So first quantity is, suppose area. Yes, And what is the formula for area? Area is L into B, length into breadth. Dimension of L is L1 and dimension of B is also L1. And B is one type of length, so it will be L2. You may remember L2, or you may write M0, L2, T0. So 0 to 0 are the powers what? 0 to 0 are the dimensions of area in terms of mass, length, time respectively. Like this, if you will choose to find volume dimension, so what it will be? So length into breadth into height. Yes, so L dimension is L1, then breadth dimension is also L1, one type of length it is, and height is also one type of length. You have to compare the quantity with 7 fundamental quantity. Yes, first you have to compare the quantity with 7 fundamental quantity. Yes, after that you can write the dimension. It will be L to the power 3. This is the dimension of volume. Yes, next find the dimension of speed. Find the dimension of speed. Speed we know, distance by time. Distance by time. And distance is one type of length, so it will be L1. And time, it is T1. So final answer will be L1 T minus 1. This is the dimension of speed. Fourth, that is velocity. Let's find the dimension of velocity. Its formula is displacement by time. Velocity is displacement by time. Displacement is one type of length, so its dimension is L1 and time dimension is T1. The final answer will be L1 T minus 1. Clear? Next is acceleration. Let's find acceleration. Here one interesting cheese is there. Acceleration, that is formula is final velocity minus initial velocity divided by time. Final velocity dimension is, final velocity means one type of velocity, that is L1 T minus 1. Then initial velocity minus L1 T minus 1. Yes, divided by time. Time is T1. अच्छा, सेम डायमेंशन सब्सट्रैक्ट करने से क्या होगा? देखो, सपोज लेट अस टेक एन एग्जांपल 3 kg plus 5 kg equals to 8 kg. For example, dimension of 3 is a number has no dimension. Kg means it is, kg means what? Kg means it is m1. Kg means it is m1 plus 5 is a number having no dimension, then again kg means m1 equal to 8 has no dimension, again it is a number, kg means m1. तो देखो LHS में क्या है, m1 डायमेंशन प्लस m1 डायमेंशन, दैट इज ऑल्सो m1. सो सेम डायमेंशन ऐड होगा चाहे सब्सट्रैक्ट होगा, जो भी करो, सो आंसर रिमेन्स सेम और डायमेंशन रिमेन्स सेम. सो हियर न्यूमरेटर पार्ट विल बी L1 T minus 1 minus L1 T minus 1, so it will be L1 T minus 1. Yep, divided by T1. So final answer is T1. Yes, so it will be L1 T minus 2. This is the dimension of acceleration. Yes, next come to next quantity, that is force. Quantity number 6, that is force. Quantity number 6, that is force. So force is equals to mass into acceleration. So mass dimension is, so F dimension is equal to mass dimension is m1 and acceleration dimension is L1 T minus 1, L1 T minus 2. Just we have derived. That means the answer is m1 L1 T minus 2. So 1 minus 2 dimension of the force. Next quantity 7, that is your work. Work is equals to force into displacement. Force into displacement. We can write W is equals to F into S. So dimension of W is equal to dimension of F into dimension of S. Dimension of F is 1 minus 2 into displacement dimension is L1. So final answer will be M1 L2 T minus 2. M1 L2 T minus 2. Next is energy. Next come to energy. You may choose any type of energy. Suppose let us take an example, potential energy. Its formula is mgh. So energy dimension, E dimension is equals to, or potential energy denoted by U. Energy dimension is equal to mass dimension is m1. Then acceleration due to gravity, one type of acceleration, that is L1 T minus 2. Then h means height is L1. So our answer will be 1 2 minus 2 m power 1 L power 2 t power minus 2. This is your answer. Then come to your quantity number 9. Yes, let us calculate dimension of pressure. Pressure is equals to formula force divided by area. Force by area. So we can write pressure P dimension. Force dimension is 1 1 minus 2. So M1 L1 T minus 2 divided by area dimension is L2. So final answer will be m power 1 L power 1 minus 2, that is minus 1. Then नीचे क्या है L2 ना, so L power 1 minus 2, that is minus 1. Then T power minus 2. This is the dimension of pressure. Yes. Next, quantity number 10. Let us calculate density. Density formula is mass by volume. Mass by volume. So density rho, density dimension is rho. Rho dimension is equal to mass dimension is m1 and volume dimension is L to the power 3. So our answer will be m power 1 L power minus 3 T power 0. Yes. Next quantity is quantity number 11, stress. Let us calculate or simply calculate angle dimension. Angle is equal to arc by radius. So angle dimension is arc is one type of length, that is L1, and radius dimension is also L1. So answer is M0 L0 T0. This is the answer. M0 N0 T0. So angle has no dimension. Very good. Next, quantity number 12, that is suppose stress. Stress formula is, this is a new quantity for you, force by area. Stress is equals to force by area. So what is the dimension of force? Dimension of force is 1 1 minus 2 m1 L1 T minus 2 divided by area dimension L2. So after solving you will get m power 1 L power 1 minus 2 is minus 1 T power minus 2. Yes. Then stress and pressure having same dimension. Then 13 is strain. Strain formula is change in length by original length. Change in length, or you may write change in dimension by original dimension. Change in length by original length. So in numerator length is there, so its dimension is L1. In denominator original length, that is one type of length, that is L1. So final answer M0 L0 T0. Yes. Then come to our quantity number 14, modulus of elasticity. Modulus of elasticity. And remember its formula is what? Stress by strain. Stress divided by strain. So what will be the dimension? Stress dimension is 1 minus 1 minus 2. Just we have written. And strain having no dimension, M0 L0 T0. So the answer will be m power 1 L power minus 1 T power minus 2. This is the dimension of modulus of elasticity. So remember, modulus of elasticity, then stress and pressure all are having same dimension. Yes. Then come to quantity number 15. Quantity number 15, refractive index. Quantity number 15, that is refractive index. Refractive index formula is what? Speed of light in vacuum. Speed of light in vacuum divided by speed of light in medium. Divided by speed of light in medium. Yes. So we can represent it as mu is equals to C by V. So what is the dimension of mu? Mu dimension is C dimension divided by V dimension. C is one type of speed, that is L1 T minus 1. Yes. General quantity dimension you have to remember. After that you can derive the critical quantity dimension. Then V dimension also L1 T minus 1. So ये क्या हो जाएगा? M0 L0 T0. So refractive index is a quantity having no dimension. Then is momentum. Momentum is equals to mass into velocity. So momentum P is equals to mv. So P dimension is how much? Dimension of P is equals to dimension of mass into dimension of velocity. So dimension of mass is m1 and velocity is L1 t minus 1. L1 t minus 1. So our answer will be m1 L1 t minus 1. m1 L1 t minus 1, the dimension of momentum. Next is 17, angular momentum. Angular momentum, simply remember the formula, mass into velocity into radius. It is a vector quantity, L vector equal to R vector cross P vector. So don't go through in detail. So simply remember the formula, angular momentum is equals to mass into velocity into radius. Okay, preliminarily your duty is to find the dimension only. So don't go through the formula, okay, detailed about the formula. So mass dimension is m1 and velocity will be L1 t minus 1 and radius is L1. So the answer will be m1 L2 t power minus 1. m1 L2 t power minus 1. Okay. Next, quantity number 18. So next come to quantity number 18. Number 18, which quantity we have to derive? We know one formula, F is equals to G m1 m2 by r square. Yes. So in this formula, what is the value of G? G is equals to F r square by m1 m2. So what is F? F is gravitational force. F is our gravitational force. And what is capital G? Capital G is universal gravitational constant. Universal gravitational constant. Universal gravitational constant. And what is R? R is the distance, and m1 and m2 both are representing mass. So can you find the dimension of G, capital G? So capital G means UGC, universal gravitational constant, dimension is dimension of force, that is 1 1 minus 2. Then r square, that is L2, divided by m1 into m2, that means m power 1 into m power 1. So after solving you will get m power is how much? M power 1 minus 2 minus 1, and L power 3, then t power minus 2. So minus 1 3 minus 2, that is the dimension of universal gravitational constant. I hope this thing is clear to all of you. M power 1 minus 2, that is minus 1, L power 2 plus 1, that is 3 t power minus 2. Then come to quantity number 19. Quantity number 19. Yes. Another formula is there. F is equals to 6 pi eta rv. F is how much? F is your viscous force. What is F? Viscous force. And remember, what is 6 pi? It is a number. Okay, ignore this thing. It has no dimension. Then eta. Eta is what? Eta is your coefficient of viscosity. Coefficient of viscosity. This is one important dimension. And r is your radius, and v is velocity. V is velocity. So from the formula we can write eta value is equals to F divided by 6 pi rv. So what is the dimension of eta? Dimension of eta is dimension of force, that is m1 L1 t minus 2. So 1 1 minus 2 divided by 1 1 minus 2 divided by your 6 pi is a number having no dimension, radius is L1, and v value is your L1 t minus 1. L1 t minus 1. So after solving you will get 1 m power 1 L power 1, and in denominator it is 2 power 2, 1 minus 2, that is minus 1, t power minus 2 plus 1, that is your minus 1. So 1 minus 1 minus 1 are the dimensions of coefficient of viscosity eta in terms of mass, length, time respectively. This is quantity number 19. Then come to our next quantity, that is quantity number 20. that is your impulse. Impulse formula is force into time. So force dimension is m1 l1 t minus 2 and time dimension is t1. So impulse dimension will be m power 1 l power 1 t power minus 2 plus 1, that is minus 1. So 1 1 minus 1, that is the dimension of impulse. Next is trigonometric ratio. So you can think about sin theta, cos theta, tan theta, any value. So that is your length by length. In that formula you will face p by b perpendicular by base, that is length by length, perpendicular by hypotenuse, that is length by length. So length by length. So it is having no dimension, m0 l0 t0. So any trigonometric function, it is having no dimension. Yes, okay. Next, quantity number 22, that is your surface tension. New to you, surface tension. Its formula is force by length. Force dimension is m1 l1 t minus 2 divided by length, that is l1. So surface tension dimension m1 l0 t power minus 2. Then quantity number 23, you may think about angular velocity or angular displacement first. Angular displacement. That is one of the angle. Yes, that is your m0 l0 t0. Angle has no dimension. Next is angular velocity. Shortly I am writing ang velocity, angular velocity. The answer will be angular displacement by time. Angular displacement divided by time. And angular displacement is m0 l0 t0 divided by the time is t1. So the dimension will be m0 l0 t minus 1. That is angular velocity. Next is angular acceleration. Quantity number 25, angular acceleration. What is its formula? Its formula is angular velocity divided by time. So angular velocity dimension is t power minus 1 divided by time dimension is t1. So it will be t power minus 2. m0 l0 t power minus 2. That is your angular acceleration. Next come to quantity number 26. That is torque. Torque formula is radius into force. So tau, we can write tau is equal to tau is equal to r dimension into f dimension. So torque dimension is equals to, you may write dimension of torque tau, dimension of r into dimension of force. Radius dimension is L1 and force dimension is 1 1 minus 2. So final answer will be m power 1 l power 2 t power minus 2. Radius into force. Next is quantity number 27. Here we can say another quantity, that is your, so many quantities have actually derived. We can think about frequency. Yes, frequency. One more quantity is frequency. Frequency is equals to formula 1 by time period. So f is equals to 1 by t. So dimension of f, that is 1 by t1. So it will be t to the power minus 1. So frequency dimension is t to the power minus 1. Okay, I hope it is clear. Yes. Then you may think about quantity v is equal to, electric charge. Quantity is electric charge, that is q. We know I is equal to q by t. So what is the value of q? Q is equal to I into t. So q is equals to I into t. So dimension of q that is equals to current dimension is A1 and time dimension is T1. So A1 T1 is the dimension of electric charge. Next, then electric potential 29. Electric potential, its formula is work by charge. So potential V dimension is equals to dimension of work divided by dimension of charge. So work dimension is 1, 2, minus 2 divided by charge dimension is A1 T1. So we may write the answer m power 1, L power 2, T power minus 2 minus 1 is minus 3, A power minus 1. Yes, this is the dimension of electric potential. Yes, after this we may think about V is equal to IR formula, that is Ohm's law. Quantity number 30. V is equals to IR, where R is equals to V by I. Electric potential, R is your resistance. Okay, so we can write dimension of resistance is equals to dimension of electric potential divided by dimension of electric current, V by I. So just we have calculated electric potential 1, 2, minus 3, minus 1. So V dimension is 1, 2, minus 3, minus 1. Yes, 1, 2, minus 3, minus 1 divided by current dimension is A1, electric current. So our final answer is M1 L2 T minus 3 A to the power minus 2. Okay, next come to our quantity, that is we can say 31, resistivity. So the related formula is R is equals to rho L by A. In class 10 we have discussed. So from this, rho is equals to RA divided by L. Yes, R is the resistance of conductor, A is the area of cross section of conductor, L is the length of conductor. So thus dimension of rho means resistivity. Rho is your resistivity. So its dimension will be dimension of resistance, dimension of area of cross section divided by dimension of L. So resistance dimension is 1 L2 T minus 3 A minus 2. Yes. Next, area of cross section, it is L2 divided by L means L1. So it will be final answer m power 1 L power 2 plus 2 is 4, 4 minus 1, that is 3. Then T power minus 3, A power minus 2. That is the dimension of resistivity. Yes. Another formula, that is your 32. Serial number 32. We know Q is equals to CV. So from this, C is equal to, you remember, Q by V. So what is C? C means your capacitance. C is capacitance. Q is your charge. Q is charge divided by potential. So we can say dimension of C is equals to dimension of Q divided by dimension of potential. So Q dimension is A1 T1. And your electric potential dimension, just we have written electric potential. Electric potential is 1, 2, minus 3, minus 1. Electric potential 1, 2, minus 3, minus 1. 1, 2, minus 3, A power minus 1. So after solving, we can say m power minus 1, L power minus 2, T power 1 plus 3, that is 4, A power 1 plus 1, that is 2. Minus 1, minus 2, 4, 2. So minus 1, minus 2, 4, 2 are the dimensions of capacitance in terms of mass, length, time and electric current respectively. This is your quantity number 32. Yes. Next come to quantity number 33, that is current density. Quantity is current density. So what is its formula? Current density equal to current by electric current divided by area. So current density J is equals to I by A. So dimension of J is equals to dimension of I by dimension of area. Yes, so current dimension is A1, area dimension is L2, so it will be M0 L minus 2 T0 and A1 T0 A1. So this is the dimension of current density. Yes, I hope what 0 minus 2 0 1. So 0 minus 2 0 1, that is your dimension of current density. So like this you can find dimensions of different derived physical quantity with the help of dimension of fundamental quantities. Okay, and what is dimension? It is the powers of fundamental quantity to which they are raised to obtain the physical quantity. This is the meaning of this concept. Yes, okay, so wait up to next lecture and do like, share and subscribe this channel. Thank you and have a nice day.